conjugate is when you have the form a plus b, a minus b. Now I want to show you how we can use that idea to help us maybe in the future. And to show you that, I'm going to just give a little twist on number 69. Okay, it's basically, I'm going to show you another way that you could solve that. Now be careful. A lot of times when a teacher shows you something new, it's like, do I have to do that? Well, we already figured out the answer to 69, but I'm showing you this idea because I know there's some problems in the future where you will need to do this. So just use this problem as a chance to see what I'm talking about. As I already said, for this problem, it's not like there's a common denominator. That's because there's only one fraction. But I can multiply by whatever I want as long as I'm doing it legally, like to the top and bottom. Now check this out. If I multiply the top and bottom by the conjugate, now that would be 1 plus cosine. That would be 1 plus cosine. Something good's going to happen. Something good. Now, it's a little different than the way Justin showed it. You have to be ready to see this. Okay. This is a little different because kids are like, am I allowed to do that? Yeah, you can multiply a fraction by whatever you want as long as you do the same thing to the top and bottom. Okay. So we multiply the top, and quite frankly, you just kind of get that same stuff. You get 1 plus cosine. You get sine squared. It's the bottom where good things happen. And now you've seen this a couple times. We just kind of want to confirm to you guys that every time you multiply a sum and difference, that's going to get you a difference of 2 squares. 1 minus cosine squared. 1 minus cosine squared. Now, that's nice, but this is why you did it. Because 1 minus cosine squared, this is kind of like the little trick here, 1 minus cosine squared. You have to force yourself to say that 1 minus cosine squared is the same as sine squared. You have to pull that little card where you take this difference of squares and you convert it back to a sine. You convert it back to a sine squared so that it can cancel with that sine squared. You're going to learn that a conjugate always gives you a difference of squares. And what that is able to do is convert to a different identity. It's able to convert to a different trig function. Okay, so of course we get the same answer. Get 1 plus cosine. Just kind of get it with a little different trick. You'll see this again. You'll use this. Okay, so I just want to sprinkle that in.
When do we use the Hart method?
Hart method. It turns out that there was no homework problem that required the Hart method, but you use the Hart method when you have a fraction where the numerator is separated with a plus or minus sign, and then there's a single term in the denominator. So addition, and then a single term, and then you would do that. Okay, now I would like to teach you guys give you a little lesson, which, as I said, it's actually a concept that everybody gets right, but I still need to show you what it is. And it ends up being something that on tomorrow's mini check, yes, there's actually a mini check tomorrow, okay, that you'll get it right. Now, I hope you get the other things right also, but this just provides something, kind of makes students feel a little bit better. By the way, tomorrow we'll practice more stuff like this. Like it's going to almost feel like today. More problems, a chance to put them on the board. But about halfway through the period, we will give you the mini check. All right, and I realize for some students it creates a little anxiety. It's like, I don't know if I'm ready, but there's a little practice tonight. I'll give you some more problems tomorrow. We're going to try to get you ready. Okay. Verify by graphing. It's actually a whole different sort of concept, but the concept is to use basically a calculator. It's going to end up being something you do on your calculator to decide if this is an identity. To decide if this is an identity. Let me give you the problem. As I said, it's actually kind of a whole different sort of goal, but you'll get it right. I'm pretty confident you'll get it right. So what I wrote on the board is tangent plus cotangent equals secant times cosecant. Now, really what we're trying to do here is we're trying to figure out, is that really an identity? Like, is that really true? Okay, now to figure that out, we're going to employ a little graphing strategy. It's actually quite simple because every expression can be thought of as a graph. So it's really like saying the graph of tangent plus cotangent. The graph of secant, cosecant. Are they equal? Are they equal? Well, let's find out. Basically we're going to graph both sides of this statement. I encourage you to play along. I'll show you up here also. I do have one sort of suggestion. Whenever you're graphing two equations, especially if you're trying to compare them, it may not be a bad idea to change what I call the style of the graph. Let me show you what I mean. Right now I'm just trying to type these in, but notice I'm typing them in as two separate lines. I like to double space just so it's not all jumbled. On a TI-83 type calculator, in the far left margin, if you've never ventured over there, in the far left margin, there's what's known as this graph style. And if I hit enter one time, I can make it a thick line. If I hit enter one time, it becomes thick. If you hit enter again and again, you get other styles that don't actually apply to what we're trying to do, but you'll cycle back to that style. I just want the second graph to look different, so I make sure I see my two graphs. Okay, now after that, it's just make sure you're in degree mode and hit zoom trig and watch the graphs. But as you watch them, you want to compare them. Are they equal? Well, you should be saying yes, okay, because clearly the one graph was on top of the other graph. And so the question really boils down to, is this true or not? Is it an identity? Again, yes, because they're the same.
Mine's saying that. Yeah, so did you say to skip Y2?
I did, just for double spacing. You hit zoom trig.
Yeah.
Okay, I think you have a little mistyping. I didn't see it, so keep looking whether you missed a parenthesis. Sometimes you miss a parenthesis, it barks at you. Go to degree mode. You are, hit zoom trig. Hit zoom. You're in degree mode. Hit zoom trig. 7. How we doing? Any other calculator concerns? It's all right. Sometimes they get a little wonky. Usually that means a scatter plot is turned on. Just highlight plot 1, hit enter so it turns off the plot. You should be good if you hit zoom trig now. Let me give you one more. If you're still trying to find like errors, I can try to look at it. Usually it's just typing something. But for the rest of you, let me give you one more problem to kind of just decide, is this an identity? Because the answer isn't always yes. If the answer is always yes, it doesn't make for a really good quiz question. You might disagree, but the question, what you're really trying to do is you're trying to figure out if this is an identity. So cotangent of x over 2, and then does that equal 2 cosine of x all over 1 plus 2 sine of x? Is that really an identity?
Did I type it in? You keep saying error.
That parentheses started right there.
Yeah.
It needs to be closed right there.
Okay.
So we'll just put a parenthesis at the end there. Oh, okay. Something's also messed up with your window. But you can fix that by just hitting Zoom Trig. It'll reset the window for you. Good. Should be right.
Okay. Thank you.
Now, how's it going typing in cotangent and all this and that? It's I can show you if you want to compare. The other thing is you really need to be careful about typing in a fraction where there's a quantity. If there's a quantity that makes up the denominator, those yellow parentheses are required. You have to add those to your input. Okay, otherwise the calculator is not really going to know how much is your denominator. You don't have to put parentheses around the numerator because technically it's not a quantity, it's just a single term, even though it has a 2 and a cosine. So parentheses, okay, as part of your input. Now this is supposed to be an example of, I even got an error. Oh. This is supposed to be an example of two graphs that are close, but no. Okay, they are not the same. This does kind of bring up the issue of how you're going to know if you typed it in wrong or if it really is supposed to look wrong. And that's a little bit, I guess, of what I'm grading, that you're just careful how you type it in. But these are not the same, so they are not an identity.
Is there a way to check those ones we did using this method?
Nice. Yeah, what do you think? I mean, every problem you guys did for homework is a yes, right? Are you thinking about that? Every problem you did for homework is a yes. So Nick, you could type in the original problem and your supposed answer. And if they look the same, then it's a yes, you know. So great question, and it's actually something I like to share. Thanks for reminding that. Listen, the sheet that I handed out to you, it's not busy work. It's a chance to kind of practice the 3 things that we've done. If you look at the top, A, B, C, okay, they're kind of just organized that way because those are the 3 things that we've done. That's what's on the mini check tomorrow. And then there's a bunch of practice problems similar to A, B, C. Put this in a homework category. Put it in a homework category.